So this we are going to talk about next class meeting with power functions in detail. Okay. If you graph this x to the power 5 like this, it's not right. Okay. And when you go home, I want you to, if x to the power 4 like this is not right. We need to pick some values in between this and see how the graph is going for these values. Okay. It's very low, so it's like touching the x-axis here. Okay. So you see, so it's okay you did this, now you know, I saw a couple of you, some of you guys did this right. So we talked about this next class meeting, and okay, so we are finding zeros, right? Finding zeros of polynomial functions, that's what we did, right? How to find zeros of polynomial function, right? And we know exactly, I gave what is zeros means 4 things, what is zeros means, we know that, right? So knowing this, so we are going to okay, I'm going to give this, I'm sorry guys. Okay, I'm going to give this theorem. We talked about remainder theorem, right? Yesterday.
We did with 3.2 with higher degree of polynomial function.
Trying to give you guys something else first, but I want to make sure. It's weird, this book doesn't have that, I just saw it. It should be here. here. See what you have here. Okay, so let me write these more theorems here. I'll go according to, I was going to give you the rational rule theorem first, but I'm going to go according to your book, okay? Okay, so repeated zeros. Repeated zeros. So, for an example, sometimes we get x, so sometimes we get x equal to 2 and there are two answers for 2, x equal to 2 and x equal to 2, like that, okay? Sometimes we have x equal to 3 and 3 and 3. There are 3 zeros, they are the same, repeating, okay? There's 3 zeros there, but they are the same number. That's what is called repeated. Okay. So this page 274, we have this. A factor x minus a to the power k yields a repeated zero. Repeated zero yields a repeated zero at x equal to a. I'll explain what this means. At x equal to a of multiplicity k. So this means two things. Then number one, if k is odd, the graph crosses the x-axis. If k is odd number, the graph crosses the x-axis at x is equal to a. Number two, if k is an even integer, even number, then the graph only touch, right? Graph touches the x-axis at x is equal to a, okay? So let me explain this. Remember we did the polynomial yesterday? Remember we did something like this. F of x is equal to, at the end we are going to factor this, something like this. If we get let's say we already factored it, we done the factored part, okay? You have a higher degree polynomial, we factored it and we got this. This is assuming you know already how to factor. Okay guys? So we already factored it. We did an example yesterday at the end, the third degree example. not yesterday, Tuesday, right? We factored it and we showed 3 factors. Okay, now we factored it. Sometimes we are going to see some factors with a k. K is an integer here. This is an integer. Okay, so we get something like this. This means we can have k. This means if you solve this, remember when we have this, we are supposed to solve this f of x, make f of x equal to and solve for x to find the x-intercept. We also discussed that. So if you solve for x, make this equal to 0 and solve, what do you get? X minus 2 whole thing power 3 is equal to 0. X minus 1 to the power squared is equal to 0. X plus 1 is equal to 0. So this become, if you take the third root of this, right? This become x minus 2 is equal to, this means x minus, oh actually you're supposed to do this. This means this, right? Right?
Yes.
So what is this means? How many x values we have? 2, 2 and 2, right? How many 1 values we have x equal to? 1, 1 and 2 x values, right? Right? How many? This is how we solve. But we don't write, if I ask to solve this, we only write x equal to 2, 1 and negative 1 like this. We don't put 3 answers when we ask to solve this. Okay? These are the x-intercept. But when we are graphing this, we need to know where the graph is going. This is if you solve for x-intercept, yes, there's only 3 x-intercept, 3 x values that touch the x-axis. Okay? These are the 3 values. Now, if you ask to graph, we need to know these two. If k is an odd number graph, what? Crosses the x-axis at x equal to a. This is your a now. So what happened at x equal to 2 here? K is a odd number. What happened to the graph? For this example, what's happening to the graph? K is an odd number. So what's happening to the graph? Graph is, so
the graph will cross the x-axis.
number 1, at x equal to 2, this is your a according to the theorem. You see that? X equal to 2, the graph, we are supposed to graph this. Remember, we were all this about graphing polynomial functions. In order to graph polynomial functions, we need to find zeros. We discussed how to find zeros last class meeting little bit. We have more theorem to do, right? After that, the whole thing is to write the f of x in terms of factored form. Now when we have in terms of factored form with powers here, there's something that we need to know about the graph. So what this means is at x equal to 2 here, that a, because k is a odd number. See, this is the factor we are talking about, this thing. This is x minus a to the power k. If you have this factor, at x, the graph, will, what happened? The graph will cross the x-axis. So the graph is going to cross the x-axis. Okay, we know that. Also, something like this, at this, the graph will, at what number? The graph will touch the x-axis. And then I'm going to do an example today to demonstrate this, right? So when we have a power 3, we know the graph is crossing. You see? X to the power 3, we know the graph is crossing. You can always remember like this. At graph power 2, what is happening for power 2?
Yeah, touching.
Touching and going to the same direction. Touching only, it's not crossing. So this is a good example for you to look at it. We already know this, right? So because we already know this, so remember this, power 3 crossing, power 2 touching. That's the theorem this theorem is saying. Okay? Okay, so we're good. So everybody understand the meaning of this theorem now? Okay, good. So there is so these are all little tools that we are going to use to graph a higher power function. If you don't know these tools, we cannot graph the higher power function. Okay? Okay, so now I'm also going to write this rule. Leading coefficient test. Okay, so there's 4 things we are going to look at with the leading coefficient test. So if we have f of x is equal to a n x to the power n. So n is the leading coefficient, n is the higher degree. We discussed this. We don't have to worry about the other. Okay? This is only the, what do you call this? Leading coefficient. We discussed this last class meeting. Whenever we have leading coefficient like this, now we are going to break this into 4 things. Number one, number 2, number 3 and number 4 thing. So first thing is, if these are the conditions, if an is the leading coefficient. If an is positive, that means greater than 0, right? An is positive, n is the higher power. This is the degree. Remember we talked about this? And n is even number. In this case, let me do it this separate. If this is the case, the graph is what? You guys remember for x squared 1, if we graph the x squared 1 is going to be like this, right? X squared 1. So what happening to the f of x? If this is f of x, this is f of x is equal to x squared. For the larger x values, when x values are going to infinity, what is the y values are going? Up. X for this one, so this is an example for this one. N is even and n is, what is n is? N is the leading coefficient. 1 means what?
It's greater than 0.
Greater than 0, positive. This means positive. N is positive. and n is even. N means the higher value, power. N is the power. This is the n, power. In here, an is with the leading coefficient is 1, n is equal to 2. Is this take care of this condition? Yes. Then when f of x goes to infinity, larger values, the function goes to larger values, the whole function, see the function is going to larger values, see? What happened to the n behavior of the function? N behavior, n means where the graph is going on both sides. What's the n behavior? Then the n behavior goes, f of x goes like this, up and up. You only have to know how the f of x is going, up. We don't have to worry about, both goes up and up, just like that one, you see? Are we following this? So when n is odd, right? I mean n is even and an is greater than 0. What happened on the other case, case 2? When n is less than 0 and this is n is less than 0 and n is even number still. Same thing when f of x goes to infinity values, larger values, right? Then the graph of f of x is going to go like this, down. It's always both ends of the function is down. This one is up, this one is down. You guys remember for this one, so this is the number 2 rule. It's the same thing as number 1 rule, but the only difference is n is a negative number. Remember we did this? Can you give me an example for this? Example for this one? How about f of x is equal to negative x squared? Right? Remember the graph is going for this one, if you graph, we know we have to do this and then we flip and then the end behavior of the graph is both going down. It doesn't have to be below x-axis. It can be about, you can have something like this. Another example, f of x is equal to negative x squared plus 4x minus 3. This one when you graph, you get a graph like this. Sorry. It's actually from negative 3. Yeah, you get a graph. You can get a graph like this, see? But the end behavior, we are only looking at the end behavior. Okay? We have to know the end behavior of the graph. Okay, so we did the two cases. Now case 3 is, what can be case 3? N is odd and n is
Greater than what?
positive, right? Greater than 0. If this is the case, then the end behavior of the graph, when f of x goes to infinity value, approach infinity value, then the graph ends of the graph goes up. Or remember for this one, you can always look at this. Remember this, x to the power 3? So the way I remember, I'm very comfortable with x squared x to the power 3. So I look at the end behavior there, and it's the same end behavior for this. N is 1 for this x to the power 3, f of x is equal to x to the n is 1, power is odd, k is odd, power is odd. So what's how the graph going? One going down, one going up. So the end behavior, one going down and the other one going up like that. You see this? One going up this way and the other one going down this way. Okay? Everybody understand that? So all you have to do is compare with this. Keep this in your mind and write this on the side. That's the same end behavior you're going to see. Any x to the power 3 function or any x to the power 5 function or any x to the power 7 function or any x to the power 1 function. One end is going that way, the other end is going down. We are only considering the ends right now. Okay? Okay. So the next, number 4 rule. Sorry? So do you have a case 4 here? What's the case 4? I'm taking a lot of time for this. Case 4.
It's less than 0.
N is less than 0. N is odd. So we can look at this, the same thing. We can say, for an example, f of x is equal to negative x to the 3. That's the model that is going to follow. Any negative odd power functions. Okay. So this is, we know this one is, how does this goes? This goes, if we take, this is the this represents this, right? Yeah, this is the reflection through x-axis. This is the right.
That's reflection through
Right?
y-axis.
So this side going up, this is going down. So think of that. Okay. So the graph, the end behavior of when larger values of x, when x is taking larger values, what is happening to the y value of the function? In this case, one end going this way, the other end going this way. Okay? Okay, this is on page 272. I did write the page there, did I? Page 272. Okay guys, so we covered that, page 272. Oh, thanks. We covered that. So applying the leading coefficient test, I will do that. We covered the 0, we covered the real, so I'm just following the book, sketching the graph. Okay, now we are going to sketch the graph. Okay. We did the remaining theorem. We use synthetic division. Okay, we have to do the rational root theorem. I'm going to do that the next 10 minutes. So we did, then I'm going to do the factor theorem and rational root theorem, then we are ready to graph, okay? So, okay, so now, so remember we talked about the next theorem is, we talked about the remainder theorem, correct? Didn't we do the remainder theorem? Last class meeting?
No.
We didn't do the remainder theorem? Okay guys, so let's do the remainder theorem and the factor theorem. Page 288. I thought we did, I'm sorry. Okay, this is very important. If a polynomial f of x is divided by x minus k, the remainder is R, I'm going to say R, is equal to f of k. That's it. So, for an example, so let's take this example. F of x is equal to 2x to the power 4 plus 7x to the power 3 minus 4x squared minus 27x minus 18. And we are going to divide this by x minus 2. Okay? And see whether the fact is we are looking for remainder first. If you know the remainder is 0, you know we can write as factor, right? If the remainder becomes 0, we can write the f of x in terms of factor, right? So what we are looking for overall, can we get a remainder a 0? Okay? So you can do this long division all the way, or you can do the synthetic division all the way and see the remainder. So do you guys want to do the synthetic division really fast?
Yeah.
Okay, let's do the synthetic division really fast. So what are you going to write? So check here. What are you going to write?
2, 7, 4, 0,
Yeah, negative 4, after that,
-27,
negative 27, and negative 18. Okay, I'm going to do this here because yesterday, last class meeting, we spent a lot of time on synthetic division. This is the last one I'm going to do. So what is my k here? What do I write there? X minus 2. Dividing by x minus 2 means the number here is 2, right? Because we're supposed to have x minus a. A is 2 now. Okay, so now we bring this 2, multiply this by 2. 2 is the factor we are going to multiply always. 4. So this is 11 multiplied by 2. 22, what is this?
18.
18 multiplied by 2,
36.
36,
9. Positive 9.
9 multiplied by 2, 18,
0.
wow, remainder 0. Okay, so remainder, we know remainder is 0. When we have a remainder 0, now I can write this because now I can say, therefore we are going to say that this is a factor of that. That's the factor theorem also. Okay? When a remainder is 0, we have a factor. X minus that A is a factor of this. Okay? So we are going to write, we can write this. So we know we can write f of x is equal to this whole thing. I can write as x minus 2 times, you look at this, right? What do you have? 2 x to the power 3 plus 11 x squared plus 18 x plus 9. So this is the remainder. When this remainder 0, we can do this. Do you guys see that? So the strategy is to come up with that remainder 0 because we want to write our polynomial function in terms of something times something times something in order for us to graph. We need to find all the x-intercepts. So now we have to do this again to this one. Okay? Now you can do the long division or synthetic division or long division or use the remainder theorem. Now use the remainder theorem for this. The remainder theorem says the remainder is f of k. Remainder is f of k. K is the same thing as your 2 here. Okay? So k is the 2. K is this value. This is k. So calculate f of k. F of k. What is f of k? What is f of 2 here for this one? For this one, what is f of 2? F of 2 is equal to 2 to the power 2 to the power 4 plus 3 2 to the power minus 4 2 to the power minus 27 2. You know how to evaluate, right? Plus 18 minus 18. Just simplify this. 2 times 64 2 times 16 plus 7 times 8 minus 4 times 4 minus 54 minus 18. If you simplify this becomes 0. So f of k, remember we got f of k, this is the remainder, this is supposed to be the remainder. 0 is the remainder here. F of k is the remainder. So if you get f of k is equal to 5 here, then we know we cannot write like this. So quickly checking whether we are getting a 0 for the remainder, substitute f of k. Evaluate f of k, that's what the remainder theorem says. Are we good?
Yeah.
So you can check with the remainder theorem. If you have like let's say example number 2, f of x is equal to x squared plus 5x plus 6, and I want to check f of 2 in this case. What is f of 2 here?
2 squared.
Let's say f of negative 2. What is this?
4
Minus
minus 6.
0. In this case we get 0, right? Therefore we know we can factor this.
Yes.
X minus 2 is a factor. X minus minus 2. So we can say, therefore, x minus minus 2 is a factor. Because we just check with this, we don't have to do the long division to see whether the remainder is 0. We can evaluate real fast. Okay? So now what do you have? X plus 2 is a factor. Okay? Let's learn that?
Yes.
Okay. Okay guys, so we know the remainder theorem, we know the factor theorem. Okay, the next thing is the factor theorem. I discuss about the factor theorem. It's on the same page. A polynomial f of x has a factor x minus k. A polynomial f of x has a factor x minus k. This is a factor if, what do you have to do here? If and only if f of k is equal to 0, because the remainder has to be 0. F of k is the 0 remainder. Remember, if you divide by this k is the, f of k is the, this is the remainder. This means if you divide f of x by this, then x minus k is a what? Factor. It's like that. X minus minus 2 is a factor. And we see that, right? We know if we factor f of x is equal to x squared plus 5x plus 6, factor this, what do you get? X plus 2, x plus 3. So f of x. Now you can say f of negative 2 is 0. If you check with this, f of negative 3 is also 0, you see. Any other things, we are not getting 0 for this remainder, if you evaluate. Okay? So remainder is 0, 0 means factor, it is a factor. X minus k is a factor. When f of k is a what? 0. So remainder theorem and factor theorem goes together. Okay? Okay guys, we are basically done. Give me 5 minutes. Okay. Now we don't have time to do the rational zeros.
So do you know what our next quiz is on?
Tuesday.
What material is it?
Huh?
Material, is it just?
Yeah, I'll let you know. Next 5 minutes, okay? Okay, so, so I'm going to do an easy one, how to graph. We still need to do the rational root theorem. I don't have time today. I was planning to do that today, but I don't have time. But I'm going to do an example here. F of x is equal to x to the power 4 minus 8x squared. So now what we are doing is graph polynomial functions by I'm just going to say graph polynomials. We are going to just Okay, so let me do an example. F of x is equal to, f of x is equal to 2x to the power 4 minus 8x. 2x to the power 4 minus 8x squared. Now, whenever we are asked to graph a polynomial, we are looking for x-intercept. Remember, always we are supposed to find the x-intercept like the quadratic function we graph. Now, if you guys are good with factoring, you think you can factor this, we don't have to use any other stuff, we're just going to factor it. Okay? If we can factor this. If we can't factor this, then we are going to use other techniques to factor. Okay? But this one, see whether we can factor this. Can we factor 2 out?
Yeah.
Yeah. So we get, what do we get? X to the 4 minus 4x squared. What else we can do here? Can we factor this?
X. Yeah.
Yes, right? So keep the 2 out. This is difference of 2 squared. So we get x squared minus 2x. A is x squared minus 2x. And x squared plus 2x. Can we also take x equal to, we can factor x also here. 2x. Factor 2x out.
2x. Yeah, so it's square.
2x squared. Okay. What do you get?
X square minus 4.
Now factor this.
X minus 1 is x plus 1.
Now it's all factored completely, correct? So now what are the x-intercepts? Zeros. First look for zeros of the graph. What are the zeros of the graph?
2.
X is equal to 0?
Yes, 0.
Yes.
0.
0. X equal to 2 and x equal to negative 2. So once we get this, we are basically good to sketch the rest of the graph. We only need a sketch, not the whole graph completely. So we are going to do this. We are going to put an interval. We are going to mark the x-intercept. Okay? Mark the x-intercept. So what are the x-intercept? 0, positive 2 and negative 2. Okay, we have this. Okay. Now after this, what we are going to do? We are going to look at 3 intervals here. Guys, you have to do this really good. We are going to look at 3. How many intervals we have here? 4 intervals in this case, right? So what are the 4 intervals here?
Negative infinity, 2 to 0.
These are the 4 intervals, right? So we are going to put a little, for each interval, we are going to have a chart here. What's the first interval? Negative infinity to negative 2. Second interval? Negative 2 to 0. And then 0 to 2. And then
2 to positive
2 to infinity. This is the interval. Now test point. Pick a test point. Remember we did that test point thing long time ago? So pick a test point here.
3.
What's the test point you're going to get? Negative 3. When x equal to negative, test point negative 3. What happened when x equal to negative 3 here? Go to the factored form and see this is going to become positive.
Positive.
This is negative.
Negative.
And this is negative.
Yes.
Negative times negative is positive.
Positive.
So it's positive, right? So the graph is positive. So this is f of x. F of x is positive. Positive means above the x-axis. Now you can find the f of 2. You can find pick a f of negative 3. What is f of negative 3 going to be? You evaluate the f of negative 3. Okay? And get that number. What happened to this interval? What's the number you're going to pick?
Negative 1.
Negative 1.
Negative 1. For this one, pick negative 1. For this interval, pick negative 1. This is pick x equal to negative 1. So what happened when negative 1?
It's negative.
Negative. Negative.
Negative. So f of x is less than 0. X equal to negative 1, this is f of x is less than 0. Less than 0 means negative. How about here? You can pick 1.
1.
1.
Negative.
It'll be negative.
Negative.
Negative?
Yes.
Negative. Right? So f of x is less than 0 for this also. Okay? And what's the other one?
3. 3.
What happened there?
Positive.
Positive, right? F of x is, so all we have to know is how the f of x is going. So once we do this chart, we are ready to graph now. So let me put this graph here fast. First we are going to get the x-intercepts. What are the x-intercepts?
0,
Zero,
2,
minus.
negative
Negative 2 and
2.
Positive 2.
positive. This is where the graph is going.
Okay.
But now we are also look at this. At x equal to 0, is graph is touching or crossing?
Touching.
X equal to 0, the graph is touching. Graph is touching. This is graph is touching. X equal to 0, graph is touched. Graph touched. This graph cross, right? Higher power is odd. And this one is graph cross, right? So we know the graph is going to cross, touch here and cross here, cross here. At this point, where's the graph? At this point, graph is positive, right?
Yes.
This interval, the graph is positive. So the graph is coming from somewhere here, okay, and going like this. All these graphs are like curves like this. These are like smooth curves. So the graph is coming this way. If you look at the NBA here, what's the leading coefficient?
2.
2 and power 4. So the graph is coming from this way, right? You look at the end behavior, you look at the leading coefficient with the end behavior, leading term, right? And then it's going to go what? At this interval it's negative.
Yes.
You can actually put that number, pick a point there where what we pick? We put x equal to negative 1, you evaluate what is the y value, okay? And you can locate that number. So the graph is going through that number. Then at x equal to 0, graph is what?
Touching.
Going here, but this is crossing.
No, touch.
Touch only, so that means it's going down. Then it has to go here,
Yes. Yes.
and then it's going up here, right? So this has the same behavior for x to the power 4? Yes, right? And do we have the multiplicity rule also? Each factor, you see the multiplicity rule? We did the end behavior and
Factor.
the factor thing and the multiplicity rule. You following it? This is, so you can write this, what is this point? You can put a point here. This is what? Negative 3 and f of negative 3. You calculate what is f of negative 3. Do you guys following this? What is this point? Negative 1 and f of
Negative.
negative 1. That's this point here. What is this point?
0.
It may not, it's not the vertex here, it could be, okay, so what is this one? F of 1 and
F of 1.
1 and f of 1, okay?